Alright, morning grade 12's final example for this section of work. And this is an applications question. With these ones, the wording can get a little bit tricky, so you just need to keep your wits about you to make sure that you don't get confused. Okay, let's have a read. The amount of instant porridge oats in packets packed by a particular machine is normally distributed with a mean of mu grams and a standard deviation of 6 grams. The advertised weight of a packet is 500 grams. So I think the first thing we need to do is define our variable x. So let's let x be the variable which is going to be the mass of oats in a packet, and we're measuring that in grams. Alright, now they've told us this thing is normally distributed, so we know mu and sigma squared, and they have then said in A, calculate the proportion of packets. Proportion, when we're talking about proportion, we're looking at percentages, okay? That would be underweight, so less than 500 grams, when mu is 505 grams. So for this part of the question, they're telling us that x is normally distributed in 505, and they told us we have a standard deviation of 6. So if we're going to draw our little distribution, remember we always draw our distribution and make sure that we are communicating, that we know what's happening in this distribution. We now have a mean of 505 grams, and we're looking for the proportion that's underweight, so it will be less than 500 grams. Alright, so we're expecting that that's below our mean, and less than means we have that area covered in. Now, we're not working with tails, we're wanting our area. We don't know what our area is, so we're going to use our calculators, but this time we're going to use NCD, our cumulative distribution, on our graphics calculator. And remember, with that one, we've got a lower value of negative infinity. So let's go back to that. We're going to distribution, normal, NCD, and our lower value is going to be negative 1 times 10 to the power of 99. Our upper value will be our 500 over there. We know that our sigma is going to be 6, and our mu is 505. So our probability that we'll have less than 500 grams inside a packet of oats is 0.2023. Alright, so that's right. Lower was negative 1 times 10 to the 99. Our upper was 500. Sigma was 6, and mu was 505. So therefore our probability of x being less than 500 is 0.2023. Okay, next question says, calculate the value of mu required to ensure that only 1% of packets are underweight. Now, we're no longer working with a mean of 505. We have to find the mean. And if we don't know what the mean is, the only way we can do that is to use our standard normal distribution, find the z-score, and then work backwards. Okay? So, we want the probability of x being less than 500 grams to be equal to 0.01. So 1% is 0.01. Let's draw our little picture there to make sure we understand what we're looking for. Always draw a picture. So we don't know what our mean is. We just know that we're only looking for 1%. That's a tiny little area over there, but we've been given it. That's going to be 0.01, and we've got that value of 500. So we can use our inverse norm. So using inverse normal on the graphics calculator. And you can see there we have a left tail. So our tail is left. Our area is 0.01. Now remember, we have to go back to our standard normal. So sigma is 1, mu is 0. And let's pop it in our calculator. So we want to go to inverse normal, distribution normal, inverse normal. We've got a left tail. So area is 0.01. Sigma is 1. Mu is 0. So that gives us a z value of negative 2.32. Okay, so our probability of z being less than z is 0.01, so z is negative 2.3263. Once we've got a z value, we can then work it back. I can put it in over here using our formula. So z is x, take mu over sigma, and we have a z value of negative 2.3263. Our x value is 500. We know that our standard deviation was 6, and we don't know what our mu was, and so we can put those values in. 2.3263 is 500 minus mu over 6, and mu is 513.96 grams. Now, we want to round that reasonably, so I would say therefore mu is approximately equal to 514 grams. We just want to round it reasonably. Okay. Let's have a look at what question C says. It says, as a check on the setting of the machine, a random sample of 5 boxes is chosen, and the setting is changed if more than one of them is underweight. Calculate the probability that the setting of the machine is changed when mu is 505 grams. Now be careful, they're talking about a sample of 5 boxes, and so instead of it being a normal distribution, now we're changing this to just a binomial distribution, which is the number of underweight boxes. So let's define that new variable. So let y be the number of underweight boxes. And can you see how sneaky we can be? Because we've got a normal distribution question, but as soon as we change the focus of it, it can become binomial. So y is now approximated by a binomial in n and p, and our n is our number of boxes. So y is going to be 5, and our probability that they're going to be underweight is going to be our initial value here, which was 0.2023, because we know that our probability, remember they said when mu is 505, they're linking that back to our original question. So 0.2023. So now on our calculator, we're not using NCD anymore. We're using BCD on our graphics calculator. And our lower value, we calculate the probability that the setting of the machine is changed, and they're looking for the setting is changed if more than 1. Now remember, your calculator uses greater than or equal to, so that means our lower value has to be 2, our upper value will be 5, our number of trials is also 5, and our probability is 0.2023. So if we look at our calculator again, we're now wanting to go to our binomial distribution, BCD. Our lower value is 2, our upper value is 5, number of trials is 5, and oopsie, 0.2023, and our probability of more than one box, well, the probability that they're going to change the settings is 0.2674. The probability of y being greater than 1 is 0.2674. So therefore, the probability that the machine setting will be changed is 0.2674.